Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into our 6th grade topic, independent and dependent variables within your equations. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below. So use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we see today, or even your own homework, you can always visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. Today's video is going to have 3 parts, so leave a like, smash subscribe, and let's get started. Before we jump into our 2 examples that we have today, let's first talk about the makeup of our equations. Now, at this point in time, you should know what an equation is, but if you don't know, no worries. I actually made a video on equations when I talked about equations versus expressions, and I'll put a link to that in the description box, so check that out whenever you feel like it. But today we're not purely going to be talking about equations. We're going to be more focused on how independent and dependent variables make up our equations. So let's first start with a random general equation. We have something like, let's say, 5x equals 10. This is going to be a very simple example of an equation. We have our constants, we have a variable, we have a mathematical operation happening here, in this case multiplication, and most importantly we have our equal sign. This is an equation. However, when we talk about independent and dependent variables, this doesn't really help us. And the main reason is there's only one variable here. If you need an independent and a dependent variable, you need 2 variables. So instead of having something like this, we need something that looks more like this. Here we have 2 different variables. Thus, we can have an independent and we can have a dependent variable. And when you have independent and dependent variables within your equation, it's going to look like this. In a very general sense, it's going to look something like this. So I'm going to change this 5 to give us a very general view of this. Actually, I'm going to rewrite all of this to give you a very general view. So we have the same y, let's say equals a, instead of that 5x. So this is going to be our constant. We have a more specific name for it called the coefficient, but it's going to be a constant, a number that doesn't change, a whole number or a decimal or a fraction. It doesn't really matter as long as it's a number that doesn't change. And this is going to be our variable. Now, this is going to be a very general view, but it can get a little different than this. Let's say you had something like this. So this is going to be another constant, but this is what we call the actual constant of your equation. This constant is another number that doesn't change. So this is a number that doesn't change, and this is a number that doesn't change. However, this is our constant, well, that will be our coefficient. The constant is going to be separate, either added or subtracted to the rest of our equation, where the coefficient has to be attached whether through multiplication or division to a variable. So these 2 are actual numbers. These 2 are going to be variables. Now, obviously our variables can be numbers, but for our general makeup, these 2 will be specific numbers that will never change, and these 2 will change depending on which type of variable they are. So now that we know that these are going to be fixed numbers and these are going to be our variables, can you guess which one is going to be our independent and which one is going to be our dependent? Remember, our independent variable is going to be the variable that you can change. However, our dependent variable is going to depend on what else is happening inside your equation. So knowing that, can you tell which one of these 2 variables will be the dependent variable? Which one looks like it depends on other things? This one. Our y looks like it depends on whatever else is happening here. As this changes, our y is going to change, right? That means that our x has to be our independent variable. So our y is going to be our dependent variable in this case, and our x is going to be our independent variable. And we wrote it like this for a particular reason. It's very easy to see that y depends on all of this in order to know what it's going to equal. Therefore, it depends, therefore dependent variable. It's going to be our dependent variable. It depends on everything here. Whereas this is going to be more controlled by us. we can throw different variable numbers in there and it's going to get a different outcome. So we like to write our dependent variable on the other side of the equal sign by itself to help us easily denote which one is going to be the dependent variable. So like I said, this is going to be our very general view of an equation. However, it doesn't necessarily have to look like this. You can have your independent and dependent variables on one side equaling some constant. However, you can always rearrange it to look like this anyway. That's going to be something we can talk about in a later video, a little bit more advanced, but for our just starting out our basics, let's stick to this setup. So now that we've talked about the makeup of our equations with our independent and dependent variables, let's look at some examples in which we're going to try to create our own equations based on what they're telling us within those word problems. In our first example, we have David ordering a pizza, and we know that the pizza is going to cost $10.50 plus $1.50 for each extra topping. We want to write an equation to find the total cost of the pizza. So the first thing we have to do is let's find our dependent and our independent variables. So our dependent and independent variables are going to be what we're going to use to create the equation, so we have to know what those are. Now we don't want to solve this. We just want to write an equation that if we did want to solve it, we could use that equation to do so. But we need to first start with our dependent and independent variables. So let's first start with that dependent. Let's look at this and see what is going to be our dependent variable. Well, looking at what we have in our word problem, we have a couple numbers. We have $10.50 and we have $1.50. Are any one of these going to be our dependent variable? Well, remember, our dependent variables is going to be something that can change, right? It's going to change and it's going to depend on everything else changing around it. Is $10.50 changing? No. Is $1.50 changing? No. So it means that none of these numbers are going to be our dependent variable. So let's look a little bit closer. Well, we see that pizza is going to cost $10.50 and it's going to be an additional $1.50 for each extra topping. And we want to write an equation for the total cost. So we have extra toppings and we have total costs outside of these two numbers. Those are some things that seem like they can change. All right, so which one of those is going to be our dependent variable? Well, which one don't you control? Do you control how many extra toppings you have? Or are you going to control the cost of the pizza? Well, you're going to control the extra toppings. So therefore, you don't control the cost of the pizza. So we're going to say T for total cost. And we're going to say E for the extra toppings, right? Extra toppings. Now, you said you can control extra toppings, but you can't control the total cost. But where do these numbers come into play? Well, that's what's going to be used to create the equation now. We know what our independent and dependent variables are now. Let's create our equation. So we want to keep our dependent variable by itself. So there's going to be a T on the left side. You can put it on the right side. It doesn't really matter, but let's keep it by itself. So T is going to be over here. And now we know we're going to have some E here for our independent variable. But what else do we have that's a part of this equation? Well, we have the pizza cost. Well, is that the total cost? No, this is going to be our base cost. So we're going to start off here and we're going to increase the cost with every topping we have. So we're going to start off here. So we're going to add that $10.50. So 10.50. We're going to start off here. This is where our pizza is going to cost if we had 0 toppings. So this is it. Now we look at this $1.50. Now this is $1.50 for every extra topping. And we said that E is going to be our extra topping. So that means that for every extra topping, we're paying $1.50. So it's $1.50 times the amount of extra toppings. So when you put all of that together, you have T, our total cost, is going to equal 1.5, which is going to be how much each topping costs, times the amount of toppings that we choose. So if you want a lot of toppings or a little bit of toppings, you control that, plus the base cost of the pizza, which was $10.50. Now we have an equation that if we did want to solve, if we had a set number for the number of toppings we chose, we can easily find out what that total cost of the pizza will be. But let's stop here and let's move on to our next example for today. In our last example for today, we have James going to the movies, and the movie ticket is going to cost $9.75. Snacks cost $4.75 each. We want to write an equation to help us find the total cost that James had to pay at the movies. So we're going to tackle this the same exact way. We need to find our dependent and independent variables before we can make our equation. So looking at this, we see we have numbers here again, $9.75 and we have $4.75. Are any of those going to be our dependent or independent variables? No, that's prefix. These are actual constants, so they're not going to be variables. So don't get caught up there. Let's read a little bit into this example. So we have snacks costing that much each. And we know that we want to find the total cost of the movie. So the total cost and the amount of snacks we buy. Those sound like variables. But which one is going to be dependent and which one is going to be independent? Well, James will be able to control how many snacks he wants to buy. So therefore, snacks can't be dependent. It's going to be the independent. And our total cost of the movie is going to depend on everything else. So that means it has to be dependent. So the total cost, we can say T again. T is going to be the total cost, while independent is going to be S for the amount of snacks. So now that we have our dependent and our independent variables, let's put it all together and create our equation. So our movie ticket is going to cost $9.75. Now that's our base cost. That means if we bought no snacks, or if James bought no snacks, that's all James has to pay. So let's start from there. We're going to write this a little bit different than our last one because it doesn't really matter how you write it as long as it ends up looking relatively the same. So we're going to start with $9.75. So I'm going to drop the actual dollar sign here. Doesn't really matter. $9.75 plus, right? Because anything else, our snacks is going to be extra. It's going to add to the cost. So we know that each snack is going to cost $4.75. So that's $4.75. Wrote that wrong there. $4.75. And we know S is the number of snacks. So depending on how many snacks, is going to be that. Let's write this a little bit better so that our 5s don't look like S's. So 475 S. And that's going to equal the total cost of our movie, T. So you see, I wrote the T over here this time. That's perfectly fine. It's by itself. We have everything else on this side. We have our base cost for the movie. We have our variable, our independent variable for the snacks that we're going to buy or James is going to buy. And we have how much each snack is going to cost. And we know that when we put all of that together, that's going to equal our total cost of the movie. So if we were to solve for this, and let's say James bought 3 snacks or 4 snacks, we'll be able to tell how much James had to pay at the movies. But for this example, we just want to create our equation, and we did just that. This is going to be our answer. So I hope you were able to follow along with today's examples, and I hope you now see how your independent and your dependent variables make up your equations. However, if you have any questions about what we saw today, or even on homework, remember, you can visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to leave a like. It really helps the channel by letting YouTube know that you found a video helpful. And if you found a video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this has been another session of Tutor Me Sempai.